Good evening. Let me introduce myself. I am Dr.R.Anitha, Assistant Professor, Department of Physics, Theoretical College, Tirunelveli. I am going to discuss about crystal physics. These are the applications of crystals. Crystals are used to the benefit of the society, like solar cells, transistors, liquid crystals, piezoelectric crystals, etc. These are the topics which I am going to discuss. Introduction. We are very well known about that matter can be classified into three different categories, that is solids, liquids and gases. Solids can be classified into two different categories, that is crystalline material and amorphous or non-crystalline materials. In the case of crystalline materials, according to the arrangement of atoms, in this case all the atoms are arranged in a periodic and regular manner. But in the case of amorphous, it doesn't have like a crystalline materials. That is irregular arrangement of atoms. This picture shows that the molecules and the unit cell, the last one is crystal. The unit cell, repetition of which gives the actual crystal structure. These are the properties of crystalline solids. That is anisotropic substance, which has a short melting point and which possess a regular shape. Example, iron, copper, carbon, germanium. Next one, non-crystalline solids. Properties. This is amorphous solids. Particles are randomly distributed, which has an isotropic substance and have a wide range of melting point. Examples, glass, plastics, rubber, etc. This slide shows that the crystal structure. Lattice plus basis, which gives the actual crystal structure. What is lattice? Lattice, which is used to identify the position of atoms, and basis means the group of atoms. These two, lattice and basis, combine together to form an actual crystal structure. Next slide shows the unit cell. What is unit cell? This is a fundamental building block, repetition of which gives the actual crystal structure. This picture shows the actually what is unit cell. Okay, unit cell. This lattice parameter used to define the unit cell. What is lattice parameters? Alpha, beta, gamma and A, B, C. These are all which we call it as lattice parameters, which is used to define the unit cell. These are the 7 crystal systems. First one is cubic, tetragonal, orthorhombic, monoclinic, triclinic, tetragonal and rhombohedral, hexagonal. These are the 14 types of Bravais lattices, that is 7 crystal systems and 4 types of lattice types. Both are combined together to form a 14 types of unit cell, that is which we call it as Bravais lattice. The scientist who introduced Bravais, who introduced the concept, so which we call it as Bravais lattice. This table shows that 7 crystal systems combined together with the 4 types of lattice types, from which we can derive the 14 types of Bravais lattices. Thank you.